Okay, question 4. Quite a big, complicated, horrible picture, but the actual stuff you've got to do is really straightforward. So, draw a vector diagram to show the components and the resultant of the velocity of the charged ink droplet as it leaves the deflecting field. Determine the size of the vertical component. We know that it's leaving at 35 degrees, it tells us that's the resultant velocity. We know that it has a horizontal component of 20 meters per second because it's given in the picture here. So we just need to draw a vector diagram and solve to find the value of the vertical velocity x. So obviously it's basic trigonometry, x comes out to 14 meters per second. That's fairly straightforward at this stage. Part 2 asks us to find the time for which the ink droplet is between the deflecting plates and hence calculate its vertical acceleration during this time. So horizontally it's going through this distance of 5 times 10 to the minus 4 meters at a horizontal velocity of 20. And that'll tell us the time that it's between the plates for, which is 2.5 times 10 to the minus 6. We then want to find what the vertical acceleration is. Well, it starts off with going completely horizontally and it ends up moving with a vertical velocity, a vertical component of 14 meters per second. So the vertical acceleration is 14 meters per second divided by the time, which we just calculated up here, and that gives us 5.6 times 10 to the minus 5 meters per second squared. Part 3 of question 4a says, for an ink droplet of mass 2.9 times 10 to the minus 10 kilograms, calculate the electric force acting on it. Well, we know force is F equals ma, Newton's second law, so we know the mass and we know the acceleration from here, so we're just basically, it's sequentially, it's just almost telling you what to do stage by stage, you know, and that gives us a force of 1.6 times 10 to the minus 4 newtons, all gravy. Next up, part 4 says, then calculate the electric field strength between the plates. So we know the field strength is force acting per unit charge. We know the force acting on our charge was 1.6 times 10 to the minus 4 from here, and if we look back in the book over here, it tells us the ink droplet carries a charge of minus 2 times 10 to the minus 10 coulombs. We have the charge and therefore we can calculate the field strength. I've ignored the minus sign here because it would just mean that the field is acting upwards, opposite the direction of this, but it doesn't matter. So that's 8 times 10 to the 5 newtons per coulomb. All good so far. Part 5 says calculate the potential difference between the deflecting plates. Well, of course, we know that electric field is V over D, therefore V is E times D. We've just calculated the field strength E from here, and we know the separation of the plates, if we look in our book here, is 1 times 10 to the minus 3 meters. So that comes out to 800 volts. All a piece of cake. But I do want to take a moment with this lot to really stress to you the importance of showing you're working. This lot here is a total of 12 marks in this booklet, a 12 mark question. Now here we did a very straightforward thing, and I sort of blushed over this on purpose when I was doing this. It's 20 equals tan 35. Okay, so obviously it is tan theta equals opposite over adjacent, but it would have been so easy to make a simple schoolboy error at this stage and just to get this bit wrong. Say you did it 20 sine 35. Now if you do sine 35, 20 sine 35 comes out to 11.4, 11.5. Nothing untoward about that. Basically, you would, if you'd done this stupid mistake and put sine in here, you would not have got an irrational or illogical number. You could have quite happily put an 11 there, carried that through and got a wrong answer there, carried that through and got a wrong answer there and there and there and there and there, all the way through. However, as long as you had shown you're working, started an equation, put in your values, you'd have got error carried forward, and you would basically have lost 1 mark at one point and got a total of 11 marks for doing this if you did that. If you didn't show you're working, you would have got nothing. And that is, or maybe 1 mark for doing the vector diagram, and then that would have been it. But you would have lost literally as much as 10 marks on a single question for not showing working. And this is, I think this question is a beautiful example of how important it is to show clear working, because that would have been such an easy mistake to make, and you could easily do that in an exam. And if you do not cover your back and cover your bases by showing your working, you could come very much unstuck on the day. So heed my words. Anyway, question part B says the uncharged, undeflected ink droplets travel beyond the deflecting plates towards the paper. With the aid of a suitable calculation, discuss whether or not the printer manufacturer needs to take into consideration the droplet falling under gravity. Well, on our picture here, it's definitely not to scale, because this is 5 times 10 to the minus 4 and this is 5 times 10 to the minus 4, so this big distance here is actually only 1 times 10 to the minus 3, which is the same as the separation of the plates. So the distance from the plates to the paper from there to there is 1 times 10 to the minus 3. The time it will take to go from there to there, if we just worry about the horizontal component, will be the distance divided by the velocity, which is 1 times 10 to the minus 3 divided by 20 meters per second, and that gives us 5 times 10 to the minus 5 seconds. Of course, that's a fairly tiny time. Let's work out how far it will fall vertically due to gravity in that time by just using the suvat, and that gives us a vertical distance due to gravity of 1.2 times 10 to the minus 8, which of course is negligible. You'd have to be working to a precision of 8 significant figures or so, or maybe 4 significant figures for this to even make a difference, okay, to anything you're doing. So it's a very small distance indeed. Okie dokie, that's question 4.